Let's do Chapter 28, Number 1. The following table depicts the output of a firm that manufactures computer printers. Printers sell for $100 each. Then we're given workers per week, a column of workers per week, and the corresponding level of output that can be produced per week with that number of workers. Calculate the marginal product and the marginal revenue product at each input level above 10 units. Well, it starts at 10 units, so those are extra words that confuse the issue. We don't have to worry about that. So that's what we're tasked with. So what I want to do is copy some of that information here on our board and go from there. So I start with labor, and I'm really just copying right now. And output. That should be a lowercase q, really. Labor and output. We have 10 workers being able to produce 200 units. 11 gets us to 218. 12, boy, I hope I have enough space. 234. 13 workers, and we could have 248 units produced. 14 workers gets us to 260 units. And 15 workers gets us 270 units. 16 workers, and we're at 278 units. So the first thing I need is the marginal product of each worker. So the marginal product of labor, if I can, and I can here because I don't have any lines, I like to sort of step down from the row a little bit, the marginal product of labor, because that helps me see that it's in transition from here to here. The alternative is to go in the second row of the choices you're looking at. So we only are looking at if we had 10 laborers. It's supposed to be 10, but they can't do anything below 10 laborers or something like that. So there's no margin to look at the first level. It's only as we've made a change, adding this 11th worker per week, that we have a change. So the marginal product of labor is equal to, in math terms, not in this simple definition, which is probably easier to get, but if we're going to identify this in math terms, I don't want to put it there, let me put it here. The marginal product of labor is equal to the change in output given some change in labor. In simple terms, it's how much more can we get by adding the next laborer. So when we add the 11th laborer, output rises from 200 to 218. Mathematically, the change in output is 218 minus 200 over 11 minus 10. So that's simply 18. And we can kind of see that. Adding that worker brought 18 more units. Now, when the 12th worker comes in, we have an increase in output, but we're going to see we have diminishing marginal product of labor. As we add more workers, we get more output, but it increases at a decreasing rate. So now I'll write this out one more time. My new level of output is 234. My old was 218. I have 12 workers, and I used to have 11. So this difference, 34 minus 18 is, let's see, that would be 12. It's 16 over 1. Let me check my answers because I got it right. So adding that worker brought us 16 units. Now, if I add another worker, output rises. But we can think of the production function. It'll rise, but not as much as it did before. So now we're going to move up to 248 units. So my change in output is 248 minus 234, which looks to me to be 14 by adding that worker. So this is 14. This is clearly 12. Adding the 14th worker brought 12 more units because of diminishing marginal product of labor. Adding the 15th worker brought 10 more units, and sure enough, that's 8 more units. So it decreases by 2. Each time we add a worker, it increases, but at a decreasing rate by a rate of 2. So that's the marginal physical product, or the marginal product of labor. I think marginal product of labor is how you'll hear it more often. So then the next thing we need is the marginal revenue product. This is a big term. But all that, what's revenue? What's total revenue for a firm? Total revenue is, always has been, always will be price times quantity. Well, these are the quantities that each adding a worker will bring to the firm. So we just need the price times that quantity for marginal revenue product. How much they bring to the table in dollars. This is how much they bring to the table in units. When we're interested in this revenue right here, it's related to this revenue right here that we're so accustomed to. So don't overcomplicate this. So the marginal revenue product of labor is really just equal to the marginal product of labor times price. And since this is a perfectly competitive firm, if I remember correctly from the question, yep, they don't affect the price. They can keep selling, the producing more units doesn't, they have a horizontal demand curve. The market will buy the units they produce without them saturating it and affecting price. If they're a monopolist, increasing production lowers the price they can receive because they're the sole producer. But this firm doesn't affect the price by producing more. So our price is always 100. So what's our marginal revenue of product of labor? It's 18 times 100. It's 1,800 of the 11th laborer. 16 times 100 is 1,600. 1,400 is 14 times 100, 1,200. 1,000, 800, and that's it. So I think that's probably the hard part, just because it's a big term, but it's really just based on stuff that we've explored before. Don't overthink it. So then in the next question, number 2, refer back to your answers in number 1 in answering the following questions. What is the maximum wage the firm will be willing to pay if it hires 15 workers? Well, 15 workers will bring to adding the 15th worker will bring to the firm $1,000. So would they pay that worker such that they would pay more than $1,000 by having the 15 workers there? By adding that worker, does that make sense? No. What would they pay up to for workers is just what the workers, as they've added them, are bringing to the table, which is $1,000. So at 15 workers, marginal product is $1,000. The 15 worker brings the revenue of $1,000. So they'd be able to pay $1,000 maximum for these workers, because that's what the workers are bringing to the table as they've added them one at a time. So that's A, $1,000 maximum. And then letter B, the weekly wage paid by computer printer manufacturers in a perfectly competitive market is $1,200. How many workers will a profit-maximizing employer hire? So, as they add a worker, what does the 11th worker cost? Given what they just said there, $1,200, because each worker costs $1,200. The 12th worker, what does the 12th worker cost? $1,200. The 13th worker, that worker costs $1,200. The wage rate is $1,200. So each time they add a wage rate, the cost of adding with the laborer, the cost of adding that laborer is $1,200. So their change in total costs each time they add a laborer is $1,200. So there's a marginal cost of labor, and that is the wage rate that they're paying. And where do profit maximizing firms operate in terms of their total costs and their total revenue? They operate, to get those parallel, they operate where marginal revenue equals marginal cost. This isn't any different. They will operate where the marginal revenue product of labor is equal to the marginal cost of labor, which is the wage rate, because it's the same all the time. And they said that's $1,200. So we know that they will pay $1,200 on the laborers, and they would stop hiring laborers when the marginal revenue product is $1,200. So that was on the 14th laborer. They would hire the 14th laborer because that one costs $1,200 and that one brings $1,200 to the table in marginal revenue product. If they added a 15th laborer, to make sure you're right, suppose they added a 15th laborer, That one would cost $1,200, but that one would only bring $1,000. It would cost more to hire that person than that person will bring in terms of revenue. So they wouldn't do that. They would stop hiring right when they reach the 14th worker, when marginal revenue product is equal to the marginal cost of labor, which is the wage rate that they have to pay. And then letter C, let me find it. Suppose that there is an increase in the demand for printed digital photos. Explain the likely effects. Sorry, I just want to make sure I'm on the right page. Yes, I am. Increase in demand for printed digital photos. Okay, explain the likely effect on marginal revenue product, marginal factor cost, and the number of workers hired by the firm. Well, if marginal revenue product is equal to price times the number of units that each worker is bringing to the table, if they can retrieve a higher price, what's that going to do to the marginal revenue product? If demand rises, price rises, and since the demand for their product is rising, they can get higher prices. Therefore, those higher prices, if this rises and this even stays the same, if it stays the same, then the marginal revenue product of labor rises. And if the marginal revenue product of labor is higher, then they could hire more labor. I hope that makes sense. Showing it here, it seems reverse, but that's just because of the way the numbers fall out here. If this number were 1,300, well, let me put it this way. If the price went up such that this became, everything became marginal revenue product became $200 more, then they would be able to hire the 15th worker, because this would be $1,200. And the workers are still costing them $1,200 each, so now the 15th worker would cost $1,200 instead of the 14th worker. So they would hire the 15th worker if demand were high enough that they could get a higher price such that we could add $200 to each of these marginal revenue products. So I'm just fitting numbers at work into these to try to bring home how it would increase the number of laborers they could hire if the laborers could bring more to the table in terms of revenue because of higher prices, because of higher demand for the output that this firm produces. So hopefully that's helpful in understanding those. I'm going to stop recording here because the other questions aren't related to this, and this is a lot of stuff between me